Hello. Good to see everyone. Okay. Right. Welcome. Welcome. So today I'm going to talk about quadratics. And yeah, so hopefully you've had a good go at our physics and maths assignments. Our maths assignments, well, our students say at least that our maths assignments tend to be easier. I don't know if you found that. So I'm going to go with some quadratics today. Right. This computer's being a bit slow. Okay, excellent. So I'm going to solve different quadratic equations. Some of them will be really easy, as you could see, the first one. Some of them would be a little bit more sophisticated, but hopefully the aim of today's session is just to introduce some of the methods we use in equations. Some of them will be familiar to you, some of them won't, but that's all right. Okay, so let's have a look. Solve by inspection. This is where you just look at the equation and you see, well, I can actually guess what it is. Like, what number would I put instead of x to make it this true? Well, there are two possibilities because I know that 6 squared is 36, and I know that minus 6 squared is also 36. Therefore, I have two solutions. Okay, so that means x is 6 or x is minus 6. We usually say x1 is 6 and x2 is minus 6, but you don't have to use this notation. The first answer. If you look at this one, you might realize that it's actually the same equation. Well, same-ish equation. They look very similar. Something squared is 36. All right, so that something could be 6 or it could be minus 6. So you could say here that 3x minus 2 is 6 or 3x minus 2 is minus 6, just in this exactly the same way. And then you can solve these two separately. So 3x equals 8, x is 8 thirds, x1 is 8 thirds, or 3x minus 2, so 3x equals minus 4, x equals minus 4 thirds, and that's x2. Do you understand on a scale of 0 to 10? 10 being I understand fully. So please vote in the chat. Okay. You can send me a direct message if you're shy, or just type it in. Okay, so something squared is 36. That means that something is that. And we just just crank it up a little bit. And that something can be very complicated, but it doesn't change anything. It's this thing squared is 36. So that means that 3x minus 2 squared plus 4. So that thing is either 6 or 3x minus 2 squared plus 4 is minus 6. And then we can unwrap this. So that's 3x minus 2 squared is 2, or 3x minus 2 squared is negative 10. So the first one, well, what number squared is 2? It's square root of 2. So 3x minus 2 is either square root of 2 or 3x minus 2 is minus square root of 2, because minus square root of 2 squared is 2, and square root of 2 squared is also 2. Okay, so what we've done here is we've unwrapped it and then unwrapped it again. So we did this sorry, the thing on the left twice. And yeah, so that's what we did. And now you solve them separately. So yeah, square root of 2 is approximately 1.4, but we try not to use approximate values in maths. So it's 3x equals 2 plus root 2. And then you divide both sides by 3. X is 2 plus square root of 2 over 3. And that's x1. x1. So 3x equals 2 minus root 2. And x2 is 2 minus root 2 divided by 3. Okay, so we've dealt with this section. Yeah, just leave it in this square root. I mean, we won't mark you down for using the approximate values, but try using square roots. Yeah. Now for this one, 3x minus 2 squared equals minus 10. What do you think happens here? Well, here is obvious. Well, here is no real solution, of course. A square of a number cannot be minus 10. So there's no solutions. No real. We don't do complex solutions. There's no solutions. No solutions because something squared cannot be equal to minus 10. That's not possible. If you square a number, it's not going to be minus 10. And that's it. We only have two solutions. Okay. Negative don't have square roots. That's another thing. Yeah, negative numbers don't have square roots. That's another reason. Although in year 13, we're doing complex numbers, and there you can have a square root of a negative number, but that's a whole other story. Okay, problem 2. This is another example where you solve by inspection. So x squared equals x. What possibilities are there? A number squared equal to itself. David, that's a good one, but almost. It's 0. Yeah, it's 1 or 0. Because 1 squared is 1, and 0 squared is 0. Therefore, there you have two possibilities. How do you show that there are no more than 2? Well, we know that a quadratic equation cannot have more than 2 solutions. That's why you don't consider anything else. Minus 1 doesn't work here, because if minus 1 squared is 1, not minus 1. So x1 is 0 and x2 is 1. So by just looking at it, you could guess the solutions. So this is by inspection. Here, a number squared is equal to 2 times that number. Well, one of the possibilities is 0, of course, because 0 squared is 2 times 0. Another way is saying, well, it can be 2, because 2 squared is the same as 2 times 2. So the second solution is 2. Thank you for your messages. Yeah. So yeah, easy. Okay, let's crank it up. Something squared is 6 times that something. I really want you to emphasize that something squared is 6 times that something. Well, again, that something can be 0, right? So 3x minus 2 is 0. Or 6, yeah. 3x minus 2 is 6, because both options work. You can replace 3x minus 2 with 0 or 6, and in both cases that would work. And then you have 3x equals 2, x equals 2 thirds, x1 is 2 thirds, and 3x equals 8, x2 is 8 thirds. Excellent. Okay, so that's that's how you solve by inspection. So you literally, you see this and you realize that this is that, which is equivalent to just saying x squared equals 6x. So very similar to that. And then you can work out the answers. So a lot of imagination, a lot of recognition. Like, a lot of the maths is about recognition, especially when you take to integrals, right? Integration is just an art. Okay. We had a joke when I was at university, and that in a family of mathematicians, you come to your parents and say, "Mom, Dad, I met someone, and they're very special." It's like, I met a girl or I met a guy, and the first question is, "Okay, do they know how to integrate?" So yeah, because that really shows if the ability to integrate is a very important skill for mathematicians. Okay, entrance assignment of a question is only worth 1 mark when you don't have to show working. I think on the action. Well, look, as long as we are confident that you didn't stick that into your calculator and the calculator, because the calculators are incredibly smart these days. As long as it's clear that that's not what you did, or you typed your question into somewhere and then got the answer, yeah, we're fine. I mean, as long as it's clear that you know how to do it. But we do ask to show your working, always. What's the Miro link? The Miro link is, I should include that in the, email that I send out. You can ask questions. You can't ask them to help you solve it. You can ask questions about, yes, that's a question. Can you ask teachers for assistance on the first assignment? Yeah, you can ask questions about quadratics, but not, can you please help me solve this? Generally, it doesn't matter if you write 1.5 or 3/2, but mathematicians tend to use 3/2 rather than 1.5. You're allowed to use a calculator. You're allowed to use anything you like. You just you can't. Look, if I have a really, really smart calculator, I can plug this into my calculator and it will give me an answer. So if I give you something like this and you give me an answer like x equals 3, I'm thinking, what's that? That's not an answer, right? Unless you show me how you got there. And how I got there cannot be, I typed that into my calculator and it gave me the answer, right? It's not 3, by the way, but am I making sense, right? If you have something like this, then you just write down the answer because there's no solution. It's a question by inspection. It's literally in the name. You just inspect it and you see that those are the possibilities. For a question like this, if you just wrote down the 2 answers, I would have questions. How did you do that? Okay. Hope that makes sense. As long as it's clear how you've done it, it can be a lot of or a little working out. Okay. Oh, is it? So I actually done the question from the exam entrance paper. I should have checked. Anyways, 2x minus 7 squared is 0. Yeah, for that question you don't have to show how you worked that out. 2x minus 7 squared is 0. Well, you know that only one number squared is 0. Any other number squared will not be 0. Would actually be more than 0. So that means that 2x minus 7 is 0. Has to be. So 2x equals 7, x equals 7 over 2. You see, I'm always leaving fractions. That's a preferred way, but I'm not insisting. Okay, so looking at this one, and if you solve an inspection question by factorizing, do you lose marks? I don't know. I can tell you one thing. Every single question 1 will be marked by the same person. Every single question 2 will be marked by the same person. And therefore, it's a fair comparison, right? So I will give some guidance for the markers, but yeah, I'd not do if it says do by inspection and you do it by factorization. I would be key. I would think you lose marks, but that might not be the case with the marker that you get for question 1, for example. Okay, so sorry, lots of stuff. So looking at the second one, can somebody tell me? Can somebody help me with that? Yeah, it is no real solutions. How come? Because this thing, this is a positive number. It's a non-negative number. So this is greater or equal 0. So it's a non-negative. 4, well, 4 is positive. Positive. A non-negative number plus a positive number cannot be 0. It's impossible. Therefore, just by inspection, I can say that there are no real solutions. Real solutions. In maths, the short way of writing no real solutions is x belongs to the empty set. X belongs to the empty set. Solutions. Okay. Yeah, you can rearrange it, but even without rearranging it, you just look at it and say, oh, that's squared plus 4. That's not possible. And And same thing here. If you look at this is squared. So this is greater or equal 0. And this is greater or equal 0. Okay, I haven't considered the case when it is equal to 0. Okay, that's not what I wanted to do. Okay, let's cheat a little bit here. +1. +1. I'm lazy at the moment. I don't want to go into that. So, and that's greater than 0. And something greater or equal 0, greater or equal 0. So non-negative, non-negative, and positive cannot be 0. Therefore, there are no real solutions. Real solutions. Okay, it's unlikely that I will give you like an equation like that, but when you, especially when you do physics and you get an equation, you always have to analyze, and you need to be able to spot these things. You can say, oh, do I even need to do anything about it? It's like, does that make sense? And then you look for cues, like square root cannot be negative. Okay, this is a positive. This is a positive. Oh, this is a really powerful way of checking yourself. Is what I'm doing making sense? Now let's look at this one. This is different. Okay, we're not doing any questions like that, but here it's positive, it's non-negative. This is non-negative, and it's equal to 0. So potentially, it looks like it's possible. The second term, because the square root cannot be negative. Square root is always positive, because that's how, if you draw the square root, the square root function is like this. Square root of x is greater or equal to 0 always. Okay. The question was, how do we know that this term is non-negative? Well, because square root. The answer is the square root cannot be negative. So yeah, this one doesn't have solutions either. Can anyone say why? Maybe try putting in a number. Put a number in. Just do trial and error. Ooh, George, one done. Well done. Yeah, whatever value of x you choose, one square root is going to be positive and one is going to be negative. So it will always be that one of the square roots doesn't exist. So never mind that. But if this is positive, for example, this one is going to be negative. And square root of negative doesn't exist. And if you say that this is negative, then this is going to be positive. Oh, this is a problem from year 12 assignment 5, I think. Oh, yes, the topic of today is quadratics, but this equation is not about quadratics. Okay, this equation is just an inspection question. It's like the ultimate inspection question. So how does that work? Well, we have to say that x minus 7, it's a square root. So you can only take a square root of a positive number. That means x minus 7 has to be non-negative. And that means x has to be greater than 7, greater or equal 7. On the other hand, this number has to be non-negative. So 3 minus x greater or equal 0, and that means x is less than or equal 3. So x has to be greater than 7, but at the same time it has to be less than 3, which is impossible. And has to be, x has to be, and impossible. Okay. Right, so moving on, and really a powerful thing is the Vieta's formulae. And I'm using the simplified version where a is 1. So where a is 1. There's a similar Vieta's formula where a is not 1. And I think one of the questions is to derive those formulae. Okay, so how does that work? Basically, if you have an equation, that means, and you have the two roots, the product of the roots is c, and the sum of the roots is minus b. So this is slightly different. This is very similar to factorization, but except you don't factorize here. You don't even need to factorize. You just write out the answers right away. So the product of the roots is c, so x1 multiplied by x2 is 2, and x1 plus x2 is minus b, so it's minus 3. So which two numbers, when you multiply them, it's 2, and when you add them, it's minus 3. Well, it's minus 1 and minus 2. x1 is minus 1, and x2 is minus 2. Now, in school, you were taught to do this by factorization. It's a very similar process. It's a very similar process. You factorize x plus 1, x plus 2 equals 0. That means x plus 1 is 0, x plus 2 is 0, and you have x1 equals minus 1, x2 is minus 2. Okay. Same thing, except here you just skip the factorization step. Somehow, I don't know why, I don't know which person is responsible for that, but this is only studied in further maths in A-level. So this is A-level further maths. Why? I don't know. It's like the easiest thing in the world. It's just that. Okay. Maybe the reason because you can use factorization, and why would you have this method if you can do factorization? I think that's probably the reason why this is not part of GCSE. So here, x1, x2 is 5, and x1 plus x2 is minus 6. In a similar way, x1 is minus 3, x2 is minus, what am I doing? Sorry. x1 is minus 5, and x2 is minus 1. So the great thing about it is you can solve them in your head, right? So you can do this thing in your head and you can just write out the answers. So here, x1, x2 is going to be minus 8, product is minus 8, the sum is 7, minus 7, so x1 is, minus 8, and x2 is going to be 1, just like that. Oh, you how do you find x1 and x2? You trial and error. Trial and error. So you think, okay, which two numbers, when you multiply them, it's 5? Well, it's either 1 and 5 or, well, it's 1 and 5. But they have to add to -6. Okay, that's going to be -5 and -1. Just like when you do factorization, how do you do it? It's going to be x plus 5 and x plus 1, right? That's exactly what you do, except you 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 have x1 and x2, and they have to multiply to 5, and x1 plus x2 have to multiply to add to -6. So it's going to be -5 and -1 plus 8. Okay, so there's a question. Shouldn't this be 8 and -1? But it's not. If you factorize it, it's going to be x plus 8 and x minus 1 equals 0. That means x equals -8 and x equals 1. Yeah? Lily and Anshu, are you convinced? Yeah, that's the thing. It is a sign swap. So look, you might find this method confusing. So I don't think I recommend using it in school. It's just another way of doing it, the same stuff. If you're comfortable doing it by factorization, don't get confused. Just don't use this method. But it's I want to show it to you because it has important implications later on. Okay, so x minus 2, so we know that x1 multiplied by x2 is 12. So two numbers, you need to find two numbers which multiply to 12. And they add to 7 because we take minus b, so they add to 7. Oh, that's 3 and 4. 3 times 4 is 12, 3 plus 4 is 7. So x1 is 3, x2 is 4. So just like that, you're solving a quadratic equation using the Vieta's formulae. Okay, 8, same thing, x1, x2 is 15, and x1 plus x2 is 8. So which two numbers, when multiplied, give you 15, when added 8, that's x1 is 5, and x2 is 3. So remember the sign inversion here, so it's minus b. Okay, here. It's going to be minus b. So the formula is x1 multiplied by x2 is c, but x1 plus x2 is minus b. So there's for the sum, you invert the sign. It's minus 7. So, that's the question from Sarmet. Sarmet, does that make sense? So here, x1 multiplied by x2. So the product is minus 8, and x1 plus x2. It's going to be 2. So two numbers multiply to minus 8 and they add to 2. So x1 is plus 4 and x2 is minus 2. That's it. Okay, 4 and minus 2. Then you can use the Vieta's formula in reverse. Write down a quadratic equation with given roots. Well, so that's x1 is 5 and x2 is minus 2. So you can work that out. So here, x1 multiplied by x2 is going to be c, right? And x1 plus x2 is going to be minus b. So from here, c is 5 times minus 2, which is negative 10, and b minus b is 5 plus minus 2, which is 3. So b is minus 3. So we worked out c is that, b is that, and a is 1 for this equation. A is 1. And therefore, we can write down the equation. So the answer, it's going to be x squared minus 3x minus 10 equals 0. So this equation has roots 5 and minus 2. And that's the answer. Yes, thank you. Thank you, those who've done the answer. Now, this equation is not unique because you can always multiply the whole thing by 2, and you get 2x squared minus 6x minus 20 equals 0. So there's infinitely many quadratic equations with the same roots. Do you have to know this for GCSE? Is that do you have to? Is that a familiar name? Have we met before? Okay. Yeah. Not this. Not this. This is not GCSE. This is this is in further maths. Yes, this is further maths A level. Unit further pure. No, sorry. Unit core pure 1. Okay. Right. Now, I had a student with the same name. So I was wondering if that's you. Sorry. Not didn't want to put you in the spotlight there. Anyways, B. Very, very similar thing. So this is x1 and x2. x1 and x2. Yeah, I reckon that. Okay, so x1 and x2. So we know that x1 multiplied by x2 and is c. So c is that. So we multiply these, and it goes 3 plus root 7 multiplied over 2 multiplied by 3 minus root 7 over 2. You multiply those. You multiply those out. So 9 minus 7 and over 4. Oh, sorry, I got carried away here. So you multiply these out. You can use the formula a minus b multiplied by a plus b, which gives you a squared minus b squared. And if you do 3 plus root 7, 3 minus root 7, that's going to be 3 squared minus, using this formula, minus root 7 squared, which is root 7 squared over 4. So that's 9 minus 7 over 4, which is 2 over 4, which is 1/2. Okay, b minus b is x1 plus x2. So you can add these. So it's 3 plus root 7 over 2 plus 3 minus root 7 over 2. So 3 and 3 is 6, and 7 minus root 7 is 0, and 6 over 2, which is 3. So b is minus 3. And so you can write down the answer. X squared minus 3x plus a 1/2 equals 0. If you're asking, I work at the University of Oxford, if that's the question, if you're asking. I work at the physics department, and my job is teaching you guys. So yes, I guess the answer is yes. You multiply by 2. You can multiply the whole thing by 2, and that gives you 2x squared minus 6x plus 1, which is equivalent. So both answers are correct. This or this, they are both equally valid answers. Okay, I hope that makes sense. By the way, I've sent you a link to the old webinars, and I've done a similar webinar on the same topic, maybe slightly easier. B is, sorry, how can you cancel like that next to the B equals minus 3? Well, if minus B, oh, when you add this, because the fractions have this common denominator. Yes, sorry, I do that. I missteps because they have the common denominator too. It's going to be 3 plus root 7 plus 3 minus root 7. So root 7 minus root 7 cancels out, and 3 plus 3 is 6, 6 over 2, and that is 3. I hope that makes sense. Oh, that's not good. Okay. The last one, 6 and root 2. So again, x1 is 6, x2 is root 2. So we write down Y10's formula. x1 times x2 is c, and x1 plus x2 is minus b. So here c is 6 root 2, because we multiply them. And b is minus b is x1 plus x2, so it's going to be 6 plus root 2. And so b is minus 6 minus root 2. So we found this. A is 1 again. Okay, yeah, I'll answer that question in a second. So that means the answer is x squared. Well, it depends on how you can write this as minus 6 plus root 2, right? So it's minus 6 plus root 2 x plus 6 root 2 equals 0. So you see, it very quickly gets more complicated, but this is a quadratic equation. Yeah, because x has x squared. U times, yes, Sharon, thank you for answering that question. You multiply both sides by minus 1. So if you got, the question was, how do you know if b is minus b is 3, b is minus 3? You multiply by, yeah. Yeah, okay, that is correct. You multiply both sides by minus 1. Or, if you're, some people don't like multiplying, they say minus b is 3. So you take minus b to the other side, and you take 3 to this side, so it's minus 3 equals plus b. And then you just flip them around, b equals minus 3. Some people do it that way. I find it disturbing, honestly. Like, so many things to do. Anyways, okay. Now, I want to show you a trick. It's one of my favorite tricks with quadratics. And you'll be surprised how often this can be used. It's like literally like every third quadratic equation can be solved using this special case. So the special case, I won't prove it if you don't mind. You can prove it by yourself, but I'll just show you how to use it without proof. Without proof. So suppose ax squared plus bx plus c equals 0. Special case 1. Case 1. Special case 1 is when a plus b plus c equals 0. Then x1 is 1 and x2 is c. C over a, sorry. Example. Well, let's take an easy example. X squared plus 7x minus 8 equals 0. You notice that 1, because the leading coefficient is 1, 1 plus 7 minus 8 is 0. That means this is special case 1, x1 is 1, and x2 is c over a, which is minus 8 over 1, so minus 8. Ta-da! Where did you get 1 from? Well, if you substitute 1 into the equation, if you get a plus b plus c. If you substitute 1 into that equation, you get a plus b plus c. That's where you get. It's just a special case rule that can be applied in some cases to solve quadratically if, yes. Example 2, example 1, example 2. 3x squared plus 11x plus let's do minus 14x plus 11 equals 0. So notice that 3 minus 14 plus 11 equals 0. Therefore, the first solution is 1. The second solution is 11/3. Okay, let's see if any of the questions that we have done comply with this. Oh, look at that one. 1 plus 7 minus 8. 1 plus 7 minus 8 is 0. So that means x1 is 1 and x2 is c over a. So it's minus 8 over 1. Done. Okay, not this one. Okay, we don't go there. Let's look at special case 2. It's very similar. Special case 2. If a minus b plus c is 0, that means if you change the coefficient of the second term and it's 0, then x1 is minus 1 and x2 is minus c over a. So example. X squared plus 10x plus 9 equals 0. So this is a special case 2, because notice that 1 minus 10 plus 9 is 0. So if you add the coefficients, 1 1 minus 10 plus 9 is 0. Notice that, and that means x1 is minus 1, and x2 is minus 9. 2. 7x squared plus 8x minus 15 equals 0. Oh, sorry, minus 8 minus 15 is 0. So notice that if we change this sign to plus, 7 plus 8 minus 15, there's special case 2, and you get x1 is minus 1, and x2 is minus c over a, which is minus 15 over 7, which is 15 over 7. So x1 is minus 1, x2 is 15 over 7. You can use special cases. If you notice them, you can use them always. And it gets ridiculously easy sometimes. Look at this, for example. Here, x squared plus 6x plus 5. If you do that's 1 minus 6 plus 5 is 0. That's a special case too. Look, minus 1 and minus 5. This one, x plus 3 minus 2. So 1 minus 3 plus 2 is 0. Therefore, it's special case 2 again. So out of 6 questions, 3 of them were special cases. Let's see if I'll just copy a random page from a textbook and see if we get any more. This is a GCSE textbook. Okay, so first one is no, not a special case. 2 plus 3 minus 1. Ooh, that's a special case. So x1 is minus 1, x2 is minus 1/2. Is that a special case? Close, but no, not a special case. 3 plus 7 minus 2, no. 2 plus 1 minus 3, yes, that's a special case. That's special case 1. 3 plus 4 minus 3 plus 8 plus 4, no, that's not a special case. No. 3 plus 8, oh, that's a special case. That's special case 1. 2, 9 minus 10, no, not a special case. No. Okay. 3 out of 11 are special cases. So yeah, I just randomly took a page from a GCSE textbook. So yeah, that's that. Using the do you understand the special cases on a scale of 0 to 10, please? Sorry, I haven't done the feedback bit. Let me know. What do you think on a scale of 0 to 10? Ooh, okay. Would you like me to do more examples of special cases? Okay. So let's do these examples of special cases. So let's do 14, 17, and then 11. So number 14. Looking at the coefficients, so 2x squared plus x minus 3 equals 0. So in here, a is 2, b is 1, and c is minus 3. If you add them, a plus b plus c is 0. And that immediately means that x1 is 1. The first solution, the first root of this equation is 1. x1 is 1. That's just the rule. As I said, I'm not proving it, but I'm showing you how to use it. The first root is 1. And it makes sense if you substitute 1, 2 times 1 plus 1 minus 3 is 0. That means it is a root. The second root is c over a. And c is minus 3, so minus 3 over 2. So it's minus 3 over 2. Does that make more sense on a scale of 0 to 10? Do you understand? But question: do you understand question 14 on a scale of 0 to 10? Okay, so this is known as special case 1. Special case 1. Case 1. Let's look at number 17. 17. So 3x squared plus 8x plus 5 equals 0. So a is 3, b is 8, and c is 5. So apologies. I'm sorry. I just have to switch off for a second. I'll still be here. Just okay. Right. So I'm back. So A is 3, B is 8, C is 5. And you notice, oh, that's special case 2. You notice that A minus B plus C is 0. So 3 minus 8 plus 5 is 0. So that's special case 2. Special case 2. And that immediately means that x1 is minus 1. And indeed, if you substitute minus 1, it's 3 times 1, which is 3. Minus 8, 3 minus 8 plus 5. 3 minus 8 plus 5 is 0 indeed. So x1 is minus 1, and x2 is going to be minus c over a. And which is minus c, so minus 5 over a, which minus 5 over 3, which is, yeah, that's it. So solve the equation by just noticing that. Wendy, sorry, what was the question? Why do we change the sign in SC2? So we changed the sign in SC2 because x is minus 1. Minus 1 squared is 1, so we don't change the sign here. Minus 1 is, well, minus 1, so we change the sign here. And 5 is 5, so we don't, x doesn't affect that, so that's why we don't change the sign. Does that make sense? Does that make sense, Wendy? kind of. The question should be, why do we not change the sign for a? And we don't change the sign for a because it's squared. That's the reason. Right. So that is how you use special case 2. And let's do number 11 as well. So 11. So 2x squared minus 3x plus 1. Oh, sorry, plus 3x plus 1 equals 0. So 2 plus 3 plus 1 is not 0, so it's not special case 1, not special case 1. But 2 minus 3 plus 1 is 0, so it is special case 2, yes. And then that means that x1 is minus 1 and x2 is minus 1/2. How well do you understand question 11 on a scale of 0 to 10, please? Okay. Good. Okay, that's much better. All right. I hope that Jawad, you can ask me at the end. I'm happy to answer. But yeah, it looks like yeah. Now there was a question: why is there almost exactly the same? It can't be. We don't question that. we do question that, and I think one of the. I'm not sure. I don't remember, but isn't one of the problems is to actually prove that. Why do you change the sign? How is 15 not a special case? 15 is not a special case because 3 plus 8 plus 4 is not 0, and 3 minus 8 plus 4 is also not 0. So yeah, so 3 plus 4 is 7, doesn't work. This one is a candidate, number 12. It looks like it should be a special case, but it's not, because 2 plus 5 minus 3 is not 0. And 2 minus 5 minus 3 is also not 0, so not a special case. But yeah. And surprisingly often, you will find the special cases. Okay. We have time for one more thing. And using the quadratic formula, derive Vieta's formulae. So basically prove Vieta's formula using the quadratic formula. That's one thing I could do. Or I could actually show you why the special case works. Why prove the special case, or prove special case. Can you vote 1 or 2, please, in the chat? Just call me sir. not a professor now. We have Professor Alex Lwowski, so he's the head of COMPOS. Using great. Ooh, lots of ones. Okay. All right, so we've used Vieta's formulae. We used that x1 times x2 is c, and x1 plus x2 is minus b. But we've never asked why, or maybe you have asked why, but yeah. So why is that? So basically, why? And I'll try to convince you that it is so. Suppose you have ax squared plus bx plus c equals 0. And you know the quadratic formula, that x is equal to minus b plus minus square root of b squared minus 4ac over 2a. So you're familiar with that. But in the Vieta's formula, a is 1. A is 1. So we use that fact that A is 1. So x is minus b plus minus square root of b squared minus 4c. So A is 1. So we kind of ignore that. 2. All right, so this is a quadratic formula if A is 1. Lovely. I don't like that. We usually write x1, x2. So I'm going to write them separately. x1 is minus b plus root b squared minus 4c over 2. And x2 is minus b minus root b squared minus 4c over 2. And I'm going to multiply x1 multiplied by x2. So it's minus b plus root b squared minus 4c over 2 multiplied by minus b minus b squared minus 4c over 2. So if you know how to multiply fractions, the bottom is 4. So you multiply them out. Minus b times minus b is b squared. Minus b times minus, so it's going to be plus b root b squared minus 4c. Plus, well, minus b square root b squared minus 4c. So it's like sometimes called FOIL. You multiply that out. And then minus square root of b squared minus 4c squared. A dot is multiplication. Yes, in maths, dot is multiplication. So 3 times 2 is 6. I know it's confusing because sometimes you write the decimal point as 3.2, but when you're dealing with this, when you use x for multiplication, it gets messy. x1 times x is like x1 x. That's why I use dot. Okay, but they are equivalent. They mean the same thing. So when I write a dot, usually that means multiplication. Okay, so now here, when you start simplifying that, this nasty thing and this nasty thing, oh, they kind of cancel out because they're the same. This minus that. And this becomes, well, it's minus square root squared, but square root squared is square root squared, like square root of a squared is a. So it's just b squared minus b squared minus 4c over 4. And if you open the brackets, it's b squared minus b squared plus 4c over 4. B squared minus b squared is 4c over 4, which is simply c. So I've shown that x1 times x2 is indeed c. Okay. And x1 plus x2 in a similar way, minus b plus square root b squared minus 4c over 2 plus minus b minus square root of b squared minus 4c over 2. If you add them up, they have the same denominator, so 2. So it's minus b plus root b squared minus 4c minus b minus square root of b squared minus 4c. Cancel, cancel. And you get minus b, so minus 2b over 2, which is minus b. Full stop. Minus 4c. Because minus, when you open the brackets, minus and minus make plus. that is hardest way to show that for real. Yeah, but it's, yeah, show that. So yes, I've shown that. You can do the same for when A is not 1. So when A is not 1, you just have to use this formula rather than this one. This only works for if A equals 1. But we know A equals 1. I think we have a question like that, very similar to that, and I would say it's a 3 marks maybe, 3, 4. Okay. Right. So that's that. I think that's all. One thing we haven't covered. One thing that we haven't covered is completing the square. Completing the square. So problem 8. Completing the square. Please watch webinar 01 from last year, from 2023. Okay. Your homework is to complete assignment 1 and 1. That's how you get in to COMPOS. Okay. So I probably have mentioned, so there are 2 different ways you can participate in COMPOS. The main COMPOS program, is the for state school students, state school UK students. There's COMPOS Foundation. That is for private school students, private school plus overseas. Okay, there's no difference in the program. It's just we get funding for state school students and we don't get funding for private school students. So private school students pay fees, which are not very high, but that helps us run the program. And then there's follow along COMPOS. This is for everyone, and it's free, and this is free, and here you have fees. Okay, so follow along COMPOS is for everyone. You're welcome to join follow along if you don't want to do everything. But this involves 4 to 5 hours of homework per week. There are tutorials in small groups. And yeah, people who actually completed COMPOS. Well, we have 50% of our of people who completed COMPOS went to Oxbridge. So just an important thing to understand. How do we hand out the assignments? You have yes. If it's a state school, you can join the main COMPOS program. Yes, that's what when you filled in the application, we find your school and we we make we make a list. Okay, so the follow along Compos submits in Google Classroom. That is in Google Classroom. Google Classroom. So if you don't want to join the main Compos program, you can do the follow along. You don't have tutorials in small groups. Homework is not mandatory. So you just do whatever you can, and if you do complete everything, you will be treated at the end of the year. You will be treated the same as a Compos main student. You will receive a letter saying that you have completed all the assignments. You have completed the Compos program. But if you choose to enter the main Compos program, yes, homework is mandatory. We expect you to show up to tutorials, so it is a commitment. Yes, so don't take it lightly. It is a lot of work. So just keep that in mind. Okay. Right. Right. Where do we find that webinar? On YouTube? Yes, I've sent a link. Today you should have received an email from me. So if you haven't checked your spam inbox, and there's a link to the old webinars. Is finding the roots the same as finding the solutions? Yes, that's the same thing. How would you submit the assignment? You would check your spam inbox again. You should have received a Google quiz. So this is how you submit, and there's a video on how to submit assignment 1. I will send that over again. Let me see if I can find it. Well, actually, I don't need to do that. What I can do is show you main. So maths 1001. Okay, so this is how you submit. You should have received a link to the maths entrance exam. You will need to answer your, you put your email, your Compos ID that has been sent to you, your name, and then you submit a file. For every problem, you submit a single file. It could be a picture or a PDF. And there's a video on how to submit. Where's that video? Not here, but I will send that over to everyone, so don't worry. If you don't receive instructions how to submit by the 5th of October, then please send us an email. But we will for sure send out instructions to everyone how to submit. You got an email. Wait, if you go to a grammar school, can you still accept my main program? Yes, you can. Got my code and stuff that tells us how to upload the Google Classroom. Yes, that is for foundation. Are their passing percentages high? So like the foundation, they're the same. Percentages for unless we really start running out of places. But generally speaking, you need to score 50%. Usually you need to score 50% to get in, but we'll keep that fair. How do we hand in assignments? It was promised an email, but haven't arrived yet. Check your spam inbox, please. If not, we will be sending out the same instructions again. Can we get into Compos? Well, we taught things beyond our curriculum. Yes. Yeah, the year 10 Compos curriculum is mostly A-level stuff. So yeah, solutions and read the same thing. Yes, I am Mr. Chernov. Can you put Compos in your personal statement? Yes, and I encourage you doing that. Although not all universities know what COMPOS is. So can you fail the main COMPOS? Well, yeah, if you don't attend and if you stop submitting homework, that means you've failed the COMPOS. But yeah, is this main COMPOS? The webinars are for everyone. So if it has webinars, and here you have just webinars. For the follow along, you have webinars, but no homework. Well, I mean, you get homework, but you don't have to do it. You don't have tutorials. So that's the difference. So the main COMPOS, you have webinars, homework, and tutorials. For the follow along, you just have webinars and homework, which is not mandatory. Right. Roughly, follow. Check today. How are you sending on assignments for maths and physics? Well, I say 4 or 5 hours, maybe 3, 4, 5 hours a week. That's the expectation. Do you have to get it right? Well, you have to. We don't give marks. We don't necessarily give marks just for the correct answers, right? We give marks for how you approach, how. Marking is based on your progress towards the answer. I found the email in spam. That helps. Okay, Teresa, how much do we need to pass? Roughly 50%. If there is an app, we recommend us doing assignments because I was having trouble to use Word. Oh, is there an app? Just if you have iPad or something similar, you can scribble. Yeah, just open a blank document and scribble, and yeah, preferably handwritten. But if you're really into it, you can latex. You can use latex, but that's tough. I wouldn't recommend you doing that. It would take ages. Will we get our scores back? Yes, you will receive your scores. Is it for both assignments? Just for we get 15? You need to score 50% in both physics and 50% in maths to get in. Yes. If you don't get into the main programs, can you still do the rest of the assignments? Yes, you can join the follow-along program and you do all the assignments. Just nobody's going to mark them. We will mark them once at the end of the year. We won't mark them as you go along. Unfortunately, we don't have the capacity because, well, we don't have enough tutors. How many places get places in 1 year group? So we have approximately 100 people per year group that will get in. How do we get an assignment? Maybe 120 people per year group, roughly. Do we get an assignment a week? No, you get an assignment every 4 weeks. So the assignment that you've seen of Physics 01 and Maths 01, you get a pair of assignments every 4 weeks. So you have 4 weeks to do it. Do we have 50 across the two? You need to get 50 in one and 50 in the other. How do you send handwritten on paper assignments? You take photographs. I've just shown you take photographs and so this is how you do it. You add file, click, you take a photograph, upload, take a photograph, upload, etc. Okay, that's how you do it. What happens if you were to get a high score in one paper, lose score in the other? Well, let's say sometimes we accept 40 and 60, right? In borderline cases, 40 and 60, but probably if you score below 40 in one of the assignments, especially physics, if you score below 40 in physics, we'll probably won't accept you. How many people have played this year? A lot, but not extreme. So it's the same as last year. last year we had 2,500 applicants, and 500 got in. But that doesn't mean we doesn't mean that we chose 1 out of 4. No, half of the 2,500, they saw the first assignment and they said, "Oh, I'm not doing it." So we only had 1,000 people actually submitting the work, and out of 1,000 people, we chose 500. So our acceptance rate is about half, and it has been for the last 3 years. Our acceptance rate has been about half. This year we have the same number of applicants as last year. Slightly fewer places, but not significantly. We have 400. We haven't confirmed because between 400 and 450 places. So yeah, about 100 people per year group, maybe 120. Okay, between 100 and 120. If you complete COMPOS', do you get a place at Oxford if you apply? Well, we don't know. It's up to Oxford. It's up to the Oxford admission. Look, we don't prepare you for the exam. We don't prepare you for PAT. We don't prepare you for MAT. We teach you how to physics. Okay. And it turns out that people who've studied physics with us, they are successful at Oxford and Cambridge. But yeah, there are several reasons for that. Yes. So first of all, those are the most hardworking people who really like physics and math. So it's not necessarily that we take just random students and we make them into superstars, but there's a lot of hard work involved. So yeah, it's we probably helped, but I wouldn't say they got into Cambridge and Oxford because of us. Yeah. And some of you your tutors will be people who did COMPOS', then they went to Oxford, and then they came back to us to become tutors. So we have several tutors like that, and you might be lucky to have them as your tutor. Okay. The tutorial starts approximately the 25th of October. So they start in a month. So yeah, tutorials start in a month. If you don't have time this year, can you apply next year? Yes, you can. You can apply for year 11. You can apply for year 12, but we don't accept any new students in year 13. Okay. All right. I think I'll finish here. Was there any question? Any more questions that you wanted to know? I don't give math problem 9 on the maths assignment. I don't know what a quadratic equation. What is quadratic equation for? I don't get problem 9. Okay, so let's see. Assignments, physics, maths, problem 9. Okay. All right, question problem 9. Generalized variations formula 8, what is the sum of and the product of the two corresponding equation 4? So if you click on equation 4, that takes you to the equation 4. Here it is, equation 4, this one. Does that make sense? All the webinars are on YouTube, yes. What if you're really bad at physics and amazing at maths? We'll do everything we can, but it is unlikely that if you score below 40% on physics, it's unlikely that you will get in. Yes. Use the term generalize. Problem 11, generalize. Problem 11. Show that the formula can be generalized. Well, formula 10 is a specific case because this is only for when A is 1. So basically what you need to do is rewrite this formula assuming that A is not 1. Basically, the formula will include A. That's what generalize means. When is the first assignment due? Is the 10th of October. If you get a question right by doing a different method than intended, it still works. Unless we ask you to do it in a particular method. So for example, if we ask you to to use a specific method, then you need to use that method. Otherwise, you can use any method. Right. Okay. Right. I'll leave you to it. And I'll see you. Oh, yes. Sorry. Next week, I think I'm going to skip the webinar. You please watch the previous webinars on the same topic. We're very busy on doing the admissions. So next week, no webinar. But watch out for emails. I'll send emails before each webinar. Okay. See you all.